This is a typical multimeter. Multimeters are able to measure voltage, current, and resistance. Most multimeters are also able to measure other values such as capacitance, frequency, inductance, and even temperature. This particular meter is of the manual ranging type. This means the user needs to set the appropriate range. This is done by selecting the measurement setting, which is just above the value that is expected to be measured. For example, voltage. This meter has setting ranges of 200 millivolts, 2 volts, 20 volts, 200 volts, and 1000 volts for DC. This means the user should have an idea of the value amount before performing the actual measurement. Selecting the appropriate range is very important for the sake of accuracy, as we will see in the demonstration. Here we have a multimeter that is of the auto ranging type. The user simply selects the measurement type and the onboard microcomputer automatically selects the appropriate range. This particular model is able to operate in auto ranging mode or manual mode by the pressing of this button. To measure voltage, the user needs to place the multimeter on the appropriate setting. Two things must be known to do this. One, what kind of voltage? Is it DC or is it AC? And the next, approximately what is the voltage to be measured? For example, a 9-volt battery. The approximate voltage to be measured is 9 volts, and batteries are a DC power source. By knowing these two things, we can set our meter on the appropriate settings. Since we are measuring DC voltage, we set our setting switch here to DC and our selector switch to 20 volts. The reason it's set to 20 volts is because this range is immediately above the 9 volts anticipated to be read off the battery. To measure the voltage of the battery, we will need our probe leads. We have our positive probe and we have our negative probe. At the end of the leads, we have banana jacks. These banana jacks will be attached to our meter through these connectors. As to which connectors are used will depend on the type of measurement that is to be taken. Taking a closer look at the connectors on this meter, the leftmost connector is for measuring voltage, resistance, logic levels, and also frequency. The next connector is your common connector, also known as your reference point. Anything measured will be compared against this reference point. The next connector is for measuring current in the milliamp range. This typically is a fused input, meaning there is a series inline fuse associated with this connector. If the current entering this input exceeds the fuse rating, the fuse will blow, thereby protecting the meter. This next connector is also for measuring current, up to 10 amps. Typically, this is an unfused input, meaning there is no fuse associated with this connector. If the current entering this input exceeds 10 amps, damage may occur to the multimeter. To measure the voltage of this 9-volt battery, we must first connect the banana jacks of our test leads to the multimeter. The black lead is the common lead. This is our reference lead. This will be connected to the common connector on the multimeter. Since we wish to measure voltage, the measurement lead, which is the red lead, will be connected to the connector for measuring volts. And now we turn on our meter. The 9-volt battery has two terminals, has a positive terminal and has a negative terminal. The voltage between these two terminals is 9 volts. To measure the voltage of the battery, we will use our test leads. The black lead is the reference lead. Whatever is measured at the red lead will be referenced in respect to the voltage at the black lead. In most cases, we make our reference the negative side of the battery. So we place it on the negative terminal of the battery. Our measurement lead will therefore be placed on the positive side of the battery. And we get a reading of 8.66 volts. If the test leads were reversed and making the reference point the positive side of the battery, what voltage would you expect to see on the voltmeter then? Remember that across the terminals of the battery there is 9 volts. But the positive side of the battery is at a higher potential than the negative side of the battery by 9 volts. So therefore, if my reference is at the positive side, therefore the negative side of the battery is 9 volts less. So therefore, we would hopefully expect to see a negative voltage. And indeed, we have negative 8.66 volts. The voltmeter is able to give us the polarity and the amplitude of the voltage being measured.